White sausages. It's kind of the national dish of Bavaria. Here it's very important that they don't get too hot and that they really only have a good temperature over a defined period of time. And this is exactly the same thing with the fixation process of your textile goods if we are talking about man-made fibers. It's very important to know when it starts. It's even more important to stop it at the right time. I will tell you how. Let's jump right in. Hello and Servus from Bavaria. Welcome to the Marlow webcast, also known as MCAST. If you're here for the very first time, then I invite you to subscribe to our YouTube channel. There you can find a lot of interesting videos and they will tell you about controlling textile processes, improving the management of those processes, and it might be a very good support for your day-to-day business. My name is Stefan Kehry. I'm responsible here at Marlow for the product management of the textile field. And today I want to talk to you about dwell time. Dwell time is essential for the fixation of man-made fibers. They require a certain period of time at a certain temperature. To do so, you have to know exactly when to start and when to stop. I will tell you in the next minutes how to identify the point when to start and accordingly also when to stop. First of all, I will introduce that subject and ask the question, what matters? Then we'll talk about safety margin and the side effects. Finally, we'll go into the benefits of a controlled process and the advantages which are resulting thereof. But first of all, let's please raise a question. Do you have an issue with your heat setting capacity? This question is rather important because it affects your stander capacity. Your stander is a very sensitive part of your production simply because in most of the cases it's the bottleneck, and due to the theory of constraint, it is the machine which is running your overall efficiency in the production. Therefore, we can't be careful enough how to operate and how to optimize this machine. So if you have any comment about it, please leave it on the comment section and we will come back to you, and I would be very glad to discuss this subject together with you. But let's just carry on. What matters during the dwell time process? So if we talk about standers, we can't really look inside. We can't really see what is happening there. We don't really recognize the temperature without the necessary sensors. So all in all, it's a little bit like a black box system. It's a mystery what's inside, and yeah, this black box still needs to be optimized. Therefore, we require a certain transparency. Transparency is not what is happening in the production most of the times, because there a lot of people, a lot of operators, they play with a certain safety margin just to stay on the safe side. It is this process control versus safety margin which is now taking the next minutes from us. So what we are talking about now is the dwell time during this entire stantering process. And as you can see, with all those sensors which we have in our portfolio, we open that black box quite easily. And by opening it, we can see what's happening inside. We can create a transparency. We can gain control, and therefore we are in the driver's seat. We don't need that safety margin anymore. But why is it so evil, this safety margin? I'm going to tell you why. Just put yourself into the shoes of an operator, and this operator might think, I really don't know when the heat setting temperature is reached. So if I don't know when it's reached, how should I know when it stops? So I rather run the stander a little bit slower and a little bit higher of temperature, and then I'm absolutely sure that the fixation period is sufficient. So this, ladies and gentlemen, leads to two fatal consequences. First of all, you have a very, very low efficiency of the stander because it's constantly running too low. But secondly, as I said before, the stander is the bottleneck of your entire production. And what does that mean? If you have a stander and you have a wet production around that stander, which is all relying on that drying capacity, all those wet finishing machines, all those dyeing machines, all those bleaching ranges, all those mercerizing ranges, all those washing ranges, they cannot drive any faster than the stander. And if you block that stander by reducing the capacity, you reduce automatically the performance of all those machines. And this is something that you don't want to have. And therefore it is essential to optimize this process. So let's take a dive into the stander and have a look what is happening in here. For the heat setting temperature, we have to monitor the temperature of the surface of the fabric, not the temperature of the chamber. No, we have to really monitor the temperature of the surface of the fabric. And this is why we do have those dwell time sensors. They are pointing right towards the temperature of the surface, and here you can already see when the heat setting temperature is reached, and from that moment onwards it is just counting. And then once this heat setting time is over, it will adapt the speed of the stander accordingly. So it will calculate automatically the time and the speed of the stander that is required to optimize this process. And that means no more safety margin necessary. You always have the right time, you always have the optimized speed. So if you have the dwell time or heat setting time of 10 meters, that means 12 seconds, you can actually, at 180 degrees, you can run with a speed of 50 meters or 40 meters or 30 meters. We do have all those algorithms in our concept, in our controls, and the computer will take care of the necessary adaptations. So your benefits are that you will save a lot of energy, you will have a much higher production output, and not only at the stander, also at all your wet finishing machines, at your dyeing machines and your bleaching ranges and so on. You have a constant and reproducible output, and you have process capability. You have a process capability that you can share with others, that you can use to improve things, that you can use to tell your customers that you have done everything right. It's like an insurance that everything really went according to plan in your production. And this is the basis of Internet of Things. This is the base of the Industry 4.0 standard. So you are already in the future when you have a sensor like that. Finally, it just simply helps you saving money. Talking about energy, please, once again, one small question. In your production, do you have an issue about energy saving still? Is it rather rising? Is it on a constant level, or is it not that severe anymore as it has been before? If you could get us that information and drop it in the comments. It would be highly appreciated. However, your advantages with that process control is that you are in the driver's seat. You don't need any safety margin anymore. You are in control of things. You can manage them. Then, by monitoring and logging into leads, you get a high transparency, a transparency that you can use to improve things, but also a transparency that you can use to increase the partnership to your customers. Then as well, you always have the same output. You always have a right first time, no matter if your operator is performing well or not that well. So no more human errors. And then finally, of course, with a modular assembly that we offer, you can start with improving your production right away. And from the very first moment, I can assure you that you will save a lot of money. So thank you very much for your time during that brief introduction in the process control. If you liked it and you haven't subscribed yet, then it is still time to subscribe to our YouTube channel. You can also get to our website www.malo.com. There we also have a video section where we have all the videos on display. There you can pick out whatever video is interesting for you and you can have a look at it. Then if you want to have that presentation, no problem at all, just drop me an email and I will send it right away. So once you're in the comments, I would be very, very happy to get a like from you. And I would be also happy if you are here again for the next webcast. And until then, I just say thank you very much and goodbye.